Alright, let's get right into problem number 1. So in each of these problems with function operations, we have to go back a little bit because it's been a while since we actually did a lot of this. But the goal here in each of these problems is to use the f, g, h, and j functions that are given at the top. And for each of the problems, they're giving us some kind of operation that we need to perform using the selected function. So for our first problem, they're saying f plus j of x. And so what that means for us is we're going to go find the f function. It's x squared plus 7x minus 18, okay? And we need to add that to the j function, which we go over to the j function is x plus 9, right? And our job is really here to just combine like terms. So we can say in this case x squared plus 8x, and we do negative 18 plus 9, we get a negative 9. So it's just as simple as combining like terms, so we need to know that that's what the notation is asking for, okay? Problem number 2 is saying f composed with j, which if you remember, when we have this little symbol here, what it actually means is to take j and plug it into f and then simplify the expression. And if we had a number here, they would actually be asking us to take that number and plug it into j and then get that answer and plug it into f. But because in this case they weren't specific, they didn't tell us what to input into j, we're just going to take the entire j expression, which in this case is x plus 9, we're going to go to the f function and we're going to plug it in. And so what that means is we're going to go to the f function, and everywhere that there used to be an x, we're going to replace it with, in this case, x plus 9. So I'm going to say x plus 9 squared, okay, plus 7 times x plus 9 minus 18. Okay, so the f function, that's what it asked us to do. It said square x, multiply x times 7, and then take that whole answer and subtract 18. Okay, so again, x plus 9 squared, don't forget, really means x plus 9 times x plus 9, so be sure to FOIL it all out. And when you do that correctly, you get x squared plus 18x plus 81. Okay, so you can expand that out and FOIL it out yourself. Okay, and then when I distribute the 7 in, I get plus 7x plus 63. Okay, minus 18. All right, so we just need to combine like terms in this case. So the x squared has nothing to combine with, so that's our easy one. I can just say x squared. Okay, I have 18x plus 7x. Well, that's 18 plus 7 is 25x. Okay, and then I have 81, okay, plus 63 minus 18. So I'm going over to my calculator on the side just to make sure that we get it right. 81 plus 63 minus 18, and that looks like 126. So a positive 126. I'm going to say plus 126. Okay, so these are two different functions. The first one we had to add, the second one we had to compose by plugging one function into the other. So let's keep going with these operations. Okay, our next problem, number 3, is asking us, is this little g to the negative 1? Looks like an exponent. What that's really asking us to do is an inverse. Right? So when I see g with this little symbol, what it really means is rewrite the expression by switching the domain and the range. So I'm going to say in this case, x equals to y minus 1, right? So which is just the y function. Let's do that again. Okay, x equals to y minus 1. Okay, and that's just the g function, but I switched the x and the y positions, and now the job is resolve it for y. Make it say y equals again. So I'm going to add the 1 over. It's going to say x plus 1 equals 2y. Divide everything by 2, and there's a couple of different ways we can format this. So you might just say x plus 1 over 2 is equal to y. That's an entirely acceptable way to leave your answer. Other people might want to actually do the division and say this is 1/2 x plus 1/2, and that would be another way of representing it. So both of them are okay as long as you get y alone and it says y equals. That's what we're asking. Okay. Problem number 4, j divided by f of x. So what this is saying is let's set up j over f in a fraction. Okay, so that would be x plus 9 on the top. Okay. And on the bottom I have x squared plus 7x minus 18, but I'm not going to write that. Instead, what I'm going to do is I'm going to come up to my f function. I'm going to say, well, wait, this is a factorable expression. This is actually x plus 9 and x minus 2, and I care about that because I'm going to look for factors in f and see if any of those factors match something in the numerator. And in this case, they do. I have an x plus 9 in both spots. Right? So I'm going to bring down the factored form of f. Right? F was in the denominator. Right? And so I'm going to make it look like that. Right? And so now I can actually do some canceling. Now that it's in a factored form, I can say x plus 9 on the top, x plus 9 on the bottom. They cancel. And here's what my final answer is going to be. I'm going to say there's nothing left on top, but we're going to leave a 1 up there because this is technically 1 times something. Okay, and on the bottom, I crossed off the x plus 9, so I'm only left with an x minus 2. Okay, so my final answer is 1 over x minus 2. However, don't forget that you need to list any domain restrictions when you do division problems. We're not allowed to have 0 in the denominator, so I need to tell people, by the way, make sure x does not equal -9 or +2, because -9 would make this first expression turn into a 0, +2 would make the second expression turn into a 0, and we're trying to avoid that. So we're letting people know that this whole thing is the answer. Here's the answer, but by the way, there's some numbers that you're not allowed to use. Okay, so that's going to be our final answer for that one. Division means factor and cancel. All right, so we got 2 more. So our next problem just says h minus f of x times g of x. So we said in this case to do your order of operations, so try to put pieces together and simplify. Okay, I would like to do this expression times this expression, but I don't know what h minus f is, right? So before I can multiply anything with g, I'm first going to do h minus f. So let's do that. H is going to be 4x squared, okay, minus x minus 5, okay, and they are asking me to subtract x squared plus 7x minus 18. Okay, so if I simplify just this piece, the answer to this is going to be h minus f. So let's do that. 4x squared minus x squared. Well, that's 3x squared. Okay, negative x, which is -1, minus 7. Well, that's -1 minus 7 would be -8x. Okay, and this is the one we got to be careful about. -5 minus -18 is like -5 plus 18. Well, -5 plus 18 would be +13. Okay, so what I'm really asking you to do is to take this expression, right, which is h minus f, that's the answer, and I want you to multiply that with g, which is this 2x minus 1 expression. Right, so now I'm going to do this big FOIL problem with the answer from h minus f, multiply that with g. So let's do that. 3x squared times 2x, well, that is 6x cubed. Okay, 3x squared times -1 is -3x squared. Okay, -8x times 2x is -16x squared. Okay, -8x times -1 is +8x. 13 times 2x looks like positive 26x, and 13 times -1 would be -13. So we just have to simplify the parts here, and we are all done. So 6x cubed is my only x cubed term, so that comes down. -3x squared minus 16x squared is -19x squared. 8 plus 26 looks like 34, so I have 34x minus 13. So the final answer to h minus f of x times g of x is this new expression 6x cubed minus 9x squared plus 34x minus 13. Okay, problem number 6. Problem number 6 is actually a kind of a little bit strange, okay, but nothing that we can't handle. Right, so in this particular problem, they're actually asking us to do an inverse. And if you remember, we did an inverse back here, right? When we did g of x, we actually switched x and y in an equation and then resolved it for y. The only problem here is they didn't give us the equation, they gave us the graph representation of k. So in this case, we don't know what x and y are to switch them. So in this case, what you have to do is first write the linear equation, and then once I have that linear equation, I can actually go through and resolve it to find the inverse. So in this case, we have to remember that all equations of all lines, okay, look like y equals mx plus b. And my m stands for slope. So we can find slope on a graph just by counting boxes. We can say in this case my rise is -1, -2, -3, -4, -5. So -5 over, and then I need to go to the right by 2, so +2. Okay? So it's actually -5 halves x. Okay? And then my b value is going to be where does the graph cross the y-axis? What is the y-intercept? Right? So in this case I can count 1, 2, 3, 4, 5. So I'm going to say +5. Okay? So the equation of this line is -5 halves x plus 5. This is what I'm now going to find the inverse of. So I'm going to switch x and y. So I'm going to say x equals -5 halves x, or 5 halves y plus 5. And I'm going to start solving. So in this case, a couple of ways that you can handle this. One way that I'm going to do that's a little bit different from the last one so you can see something new is I'm going to multiply everything by 2. And in this case, what that's going to do is get rid of this divided by 2. So it's going to become 2x negative 5y, or equals negative 5y, okay, plus, and don't forget to multiply this by 2 as well, plus 10. Right? So what I did was I multiplied everything by 2, so I added 2 attached onto x. It canceled out the dividing by 2, and it multiplied the 5 by 2 as well. So everything got multiplied by 2. Now it's pretty easy to solve. I can subtract over the 10, and it becomes 2x minus 10 equals 5, or negative 5y. Okay, and then I can divide everything by negative 5. So again, how you simplify this, we're going to say in this case negative 2/5. And when I do negative 10 divided by negative 5, I get a positive 2. So negative 2/5 x plus 2, that would be the inverse, right? So in this case, we just had to do a little bit of extra work because we had to find the equation of the line, and then once we had the equation of the line, we had everything that we needed in order to take the inverse of our graph.